Let's continue. Because I was never really happy with the surface finish on this side. Now on this side is okay-ish, but it's less important because there will be all kind of features here. But this side will stay as is, so it will be visible. So what I would like to try, I tried earlier on another part with this fly cutter, but with this little insert there is a little bit too much tool pressure and the thing is wobbling and it leaves a crappy finish. But I have inserts for aluminium, nice and sharp and way less tool pressure. So let's give these things a try in here. I have to change these jaws because even completely open the thing doesn't fit. So let's do. All installed and ready to go, I think, and at least this time I was smart enough to first install my workpiece and then the cutter, so I didn't cut myself this time. And because this part here is a lot of stick out, it's hanging over here in the nothing, when I touched off there was a terrible chatter. So I installed this block here and the machine is jack. So now let's see if it works. I think it can use some finer feed and a higher RPM. It is indeed a bit better. Not spectacular, but just a bit better. The thing is again more or less reassembled and it looks a little bit better now. Okay, let's make another part. To make, for example, what's marked here as part 11, for the moment I can't make yet because I ordered a tap and didn't arrive yet. So no problem, let's make part 6 and 7. This is the anvil where the sliding part will bump against. And because it has more or less the same dimensions than the hold down V system for the longer part, why not make them as one piece and cutting them two? And I don't have the right material to do this, so I will use, this was a shim that I made specially to hold the drum brakes in place to cut the grooves inside. And because now it became useless, let's make something else out of it. Because this thing is in a paper and here of course is a cutout, it will be a little bit complicated to hold it in the vise. But because there's two holes in here, I'm gonna use these to bolt the thing directly on the table. So this vise can go. I left it a tiny bit oversized on the thickness. So I will give it a finishing pass with my parting tool. This leaves a nice finish normally. But before I do that, first I will square up this little surface. And that's of course the reason why I switched the clapper box to this side. The beautiful finish will be probably for next time because it's a complete failure. But whatever, let's part it off. I'm gonna give it a little bit more stroke length because sometimes the tool doesn't come out. It will be easier to take it off if I take it off. Here you go. Before I cut this thing in two, because of course these are two parts in one rough thing here, it's maybe a good idea to first make this radius that I already tried out here. And this is radius, and of course combined with a radius on this side. Because now I have a lot of material to hold on the belt sander. If one day you have to make completely impossible shapes on a workpiece, the belt sander is your friend. Belt sander and a little bit of sandpaper and not even 5 minutes. And ready for action. And another part finished and mounted. Right, let's make this one out of course, this here. And according to the plans here, it needs two holes that are not in line and they are not round, but we'll see, no problem. And when I hold it in this way, one side needs to be 18 millimeter and the other side 20.5, which means here we have an angle. And this angle is not marked on the plans, but it is 15 degrees 30 minutes. And I think if even I could figure this out, you can do better. Because two of the surfaces here doesn't have a very nice finish, I will install it this way. This surface is okay-ish and this one too, and these surfaces will be visible in the assembly. So the invisible surfaces this way. And because this is a 12 millimeter end mill, all I have to do is move my table 6 and the center line is exactly over the 0 of my part. That could work. Of course, I'm not going to use these bolts. I would like more bolts like these here, just for the looks, but I don't have any more. I have in M5, M4, M3, but these of course are M6. But whatever. I see here that there's a lot of slop in the thing, so that's good. That's for the adjustment, of course. But I'm not sure there will be enough here, because when I look at the plans, normally the top side of the body and of this adjustment piece must be more or less in line. And for the moment it's almost, but not enough. But I can also adjust it with we'll see. Right, let's make this 15.5 degrees thing here. And I think it won't be too complicated, because the maximum tilt of the dividing head here is 15 degrees, maybe a tiny bit more, we'll see. And I will tilt it that way, because if I want to tilt it this way, that's not gonna work because of this block here, which is gonna touch the table. So that way it will be. Touching somewhere. It looks like the maximum angle I can give this thing is 14 degrees. But I think that will do, because as long as this part that I'm gonna make now, of course, and the matching part has the same angle, they should work. And now there's again a small problem. If I want to install my part right here, and then of course close the vise, I have a gap here. The head is completely that way. So to be good, my vise should come over here. But if I take, for example, the second parallel and I put a bigger one on top, more or less this idea, part in place here and tighten. That could work. I think it will work just fine as is. All I have to do, but I will do later, is make this round feature here, make it look more beautiful-ish thing, I don't know. Right, let's start making this sliding piece here. And I think this is the most challenging part of the assembly. I made it a little bit bigger here on the backboard. This part has the same 15.5, but now in this case it will be 14° angle on the top. This is a sliding part. And the sliding action is provided by a threaded rod, which means that this cutout, inside the cut, there is this thread form. A radius of 4.5mm bore, if you can call it a bore, but it is eccentric. 4.5, and between the center of this radius and the side of my part there is only 3.75mm. So my plan is, and about 2 of you also noted in the comments, is to make this part way bigger, like this, make the complete hole through and then cut all this material away again. And of course I thought of this after I cut this one. Total width here 9mm, and I have here a piece 9mm. So this is not gonna work. What could work is this one. This one is 19mm, so way too big. So before we do the complicated stuff that's marked here, first let's cut it to more or less length and square it up in the shaper. Because of course the milling machine is still set at 14°, and for this part, for the finish, I need this 14°. So the shaper it will be. And of course also because shapers are fun. The thing is roughed out and I checked it for squareness and parallelism. Now never mind these holes here, this will disappear because I'm gonna cut it off about here at this length, so this, no problem. So I checked for parallelism and squareness and it is parallel, so that's good, and it is not square. Now, it's not far off, but it's not square. So I gave my vise here a sweep. Of course I took off the moving jowl a sweep with the indicator, and these two rails, they are parallel with the horizontal movement. So this is good. It's just that the fixed jaw is not square. So this is a upcoming project, one of these days, maybe. I wrote some anti-bozo lines here on my part, and the plan is to drill it out here in the lathe using the 4-jaw chuck. But because I want to drill and tap in one and the same setup, of course, and the tap didn't arrive yet, I suppose it will be for next week.